Hello. I'm going to assume that you've already learnt about factorization and you just want a reminder from this video. But if you're unsure about factors and highest common factors, then try this exercise here first. Or if you can't remember how to expand brackets, well, try this exercise before you start on this factorization exercise. But if you're ready to go, let's have a reminder. So the first exercise really requires you to know what highest common factor means. So let's have a look at two numbers, 8 and 12. Well, they both have got the factor of 2. That means 2 will divide exactly into both of those numbers. So we can say that 2 is a factor of 8 and 12. But there is also another number, a higher number, 4, which goes exactly into 8 and 12. So we say that 4 is the highest common factor of 8 and 12. There are no numbers larger than 4 that will divide exactly into 8 and 12. So that's what highest common factor is, sometimes abbreviated as HCF. So if you do need practice, this is where you need to go to have a little bit of practice, but otherwise, let's look at some examples. So here's some examples at level 1. What we have to do is find a common factor in the two terms, and we want to find the highest common factor. So here we have a b in the first term, and this second term is just a number. But I can see that the highest common factor of the 15 and the 9 is 3. So rather than expressing the 3 twice in both of these terms, we can bring it in front of a set of brackets to show that everything inside must be multiplied by the 3. So the way I do this is divide that by 3 now to get 5b. And then divide that by 3 just to get plus 3. So now if you multiplied out this bracket, multiplied everything by the 3, you would get 15b plus 9. So this is a sort of more compact way, in some senses, of writing this expression. Let's have a look at this one. 25 and a 30. I can see the highest common factor is 5. So I'll divide that by 5. So that gives me just 5c left. And then divide that by 5 will give me a plus 6. So the factorized form of that expression is 5 lots of 5c plus 6. Now this one has got 3 terms, and the highest common factor I can see is actually only 3. So I'll put the 3 outside the brackets, and that will give me 11 plus 12j plus 11p. And finally, 14, 6, 34, different letters here. Highest common factor is 2. So it's 2 lots of 7 minus 3k minus 17q. Right, now it's your turn to have a go at the online exercise. Don't forget to press the check button frequently to see if you're getting the questions right, and then come back here for level 2. Now I can see that these two terms here have a common factor of a. So I can bring a in front of the brackets and multiply that by 2 plus b. Let's just check. If I multiply everything in the brackets by a, I will get 2a and ab. So that's correct. I see these two terms have a common factor of e, because we have an e squared here and an e there. So I'm going to bring the e in front of the brackets, then have 13e minus 2. And again, check when you multiply these two terms by e that you get back to where we started. Right, now we have quite a lot going on here. But the only common factor of these two terms is the letter j. So that goes in front leaving me with 13q plus 31p. And finally, this has got 3 terms, and the only common factor is k. So k will go in front of the brackets to leave us with 41k minus 2 minus 7q. And then don't forget to check it by multiplying everything inside the brackets by k to see if we get back to where we started. When we get to level 3, you'll notice that these 2 terms have got a common factor in the numbers, the 2 and the 14, got a common factor of 2, but also we have a factor of b here and b there. So I can actually bring out both of those, the 2 and the b, and then what I'm left with is 7 here, and if I divide that by the 2b, I'm left with a c. So let's check we get back to where we started if we multiply everything inside the brackets by the 2b. 2b times 7 is 14b, correct? And 2b times c is 2bc, correct? That must be the right answer. I can see straight away a common factor of 5 here and a c. So that will leave me with a 3 at the beginning and a d at the end. And again, check that when you multiply the 5c by those 2 terms, you do get back to where you started. All right, these are a little bit more complex now. We have an 18, a 12, and a 66. So I know that 6 is a common factor. And then let's look at the letters. I can see that there is definitely at least one k in each of the terms. So I can put a k in front of the brackets, and then it just leaves me to work out what I need to write inside the brackets to get back to where we started. So here we have an 18, now we have a 6, so I need a factor of 3, and because it's k squared, I need to have a k there, so that when 6k is multiplied by 3k, you do get 18k squared. Minus, so let's divide that by 6k, and we get 2, and then another minus sign. 66 divided by 6 is 11, and we've got a factor of k there, so we don't need another one. That is the answer to that. So finally at level 3, 30, 42 and 12, the highest common factor is 6, and we've got a letter y there. So 5y is the first term, plus 7r is the second term, plus 2yr is the third term. And if you're not sure how I got that, well, multiply everything by 6y and you'll see we get back to where we started. What we did technically is each of these terms we divided by the common factor that we were taking outside the brackets. Okay, have a go at level 3 in the online exercise. Press the check button regularly and then come back here for level 4. Now, all the examples at level 4 have got 4 terms. And I can see straight away that these first 2 terms have got a common factor of a. So I can write these as 3a plus b. Oh, and I notice that the second 2 terms have got a common factor of w. So as we can't factorize everything, it's only really partially factorized. So this one, the first 2 terms have got a common factor of c, and the second 2 terms have got a common factor of w. Here, the first two terms have got a common factor of a. And the second two terms have got a common factor of both 7 and w. So if I'm taking out a factor of 7w here, that needs to be multiplied by 1 to get back to where I started. So I'll put a 1 inside the brackets. And then here, 28 divided by 7 is 4. And then I've already got the w, so I just need the y. And finally, this one, I'll rearrange it before I do the factorization. And I'll put them in pairs with common factors. So the first two terms, I've got a common factor of g. And the second two terms, I've got a common factor of j. So that's how you factorize those expressions, but technically it's just partial factorization because we're still adding two expressions together. Now you have practiced at level 4, level 5 should be more satisfying. Let's have a look at these expressions. I can take c, and that will leave me with a plus b. And then in the second pair, I can take out a d, and that will leave me with a plus b. But here's where it gets interesting, because can you see the brackets here? They're both exactly the same. A plus b and a plus b. So we've got two expressions added together with a common factor of a plus b. So actually that can be brought in front of a set of brackets, and we just have the c plus the d in the second set of brackets. I'll do it again until you get the idea. First two have got a common factor of m. The second two have got a common factor of 4. And then I notice that the two brackets are the same. So let's bring that out as a common factor, and that will leave me with m plus 4. Okay, this one we have a common factor of t at the beginning, and then a common factor of u, and the brackets are the same. Voila! Finally, this one. Be careful with the negative signs. Let's see how we go. First two, common factor of b. And then the second two don't have a common factor. So I'm just going to write down the minus sign, and I'm going to put them in brackets. And this minus sign is going to apply to the whole of these brackets, so that we do want negative c, there, we've got a minus c, but we want positive d. So because we're multiplying by this negative imaginary 1 that's in front of the brackets, I'm going to make this minus d, because can you see that the negative of minus d is positive d? These two negatives go together to make a positive in this particular case. So multiplying minus d by minus 1, so to speak, will give us the positive d. And now we can see the two brackets are the same. And that was effectively a 1, so I can put 1 there. Okay, have a go at level 5. Press the check button regularly to see if you're getting the questions right. Now at this point, if you're not really confident with expanding brackets, have a go at the brackets exercise, and here is the address. But by doing that exercise, you'll come across this special case of multiplying out two brackets. Now, when you multiply out the brackets, the a is multiplied by the a to give you a squared, and then the b and the a are multiplied together to give you ab, and then this a and this negative b are multiplied together to give you negative ab, and these two are multiplied together to give you b squared. So you end up with this, a squared plus ab minus b squared. So when you collect like terms, you'll notice that the plus ab and the minus ab will cancel each other out, and you're just left with a squared minus b squared. And this we call the difference between two squares. A squared is a square. It's the area of a square with sides of length a. And b squared is also a square number. And the minus sign designates difference. So we call this the difference between two squares. So if we take away the working, what you can remember is that for the difference between two squares, if you factorize them, you'll get a plus b, lots of a minus b. Okay, that will come in handy with this next exercise. So can you spot these examples are all examples of the difference between two squares? You see here we have c squared, and here we have 81, and 81 is a square number, it's 9 squared. So it's c squared minus 9 squared, the difference between two squares. So you can write it down as c plus 9 multiplied by c minus 9. This is the difference between two squares because 25 is 5 squared, so I can write this down as 5 plus d, 5 minus d. Here we have two squares because 4a squared is actually 2a all squared, and 9b squared is actually 3b all squared. So I can write this down as 2a plus 3b lots of 2a minus 3b. And finally this one, just check that I get this right. 12a plus bd lots of 12a minus bd. And the way you can check it is by multiplying out the brackets and seeing if you get back to where you started. Okay, have a go at level 6 online. So let's have another refresher about multiplying out brackets. Here we have a pair of brackets multiplied together. Everything in the first bracket must be multiplied by everything in the second bracket. So this x has to be multiplied by this x to give x squared. 3 multiplied by x is 3x. That x multiplied by the 4 is 4x. And finally, the 3 multiplied by the 4 is 12. So altogether you get this. And if you collect like terms, in this case just the x's, you can shorten this to x squared plus 7x plus 12. Now if you look closely, you'll see that that 7x in the middle, the number 7, is what you get when you add together the 3 and the 4. And the number 12 at the end is what you get when you multiply the 3 and the 4. Well, that can be quite handy. In level 7, we have some standard quadratic expressions. But each of them, the squared term, the coefficient is effectively 1. So we have x squared, y squared, v squared, and w squared. So we can actually factorize these all in one go by inspection, as it's called. So we know it's going to be two sets of brackets. And I know that I'm going to have the x at the beginning of both of the brackets. And then the two numbers at the end of both brackets have to multiply together to give positive 6. And these two numbers have to add together to give 5. So I think they must be plus 2 and plus 3. It's the sort of thing that you can do in your head, and it gets easier with practice. So the steps are, first of all, draw the brackets. Second, the letter can go at the beginning of both brackets because we know that when we multiply those two together we'll get the y squared. Now the numbers, when we multiply the numbers together, we need to get negative 15. But when we add these two numbers together, we need to get negative 2. So you'll have to play around with the factors of 15. And because it's negative 15, you know one is going to be positive and the other is going to be negative. That's the only way you can get a negative answer. So is it 3 and 5? Well, if we have positive 3 multiplied by negative 5, we do get negative 15. And does that also give us the negative 2 when we add them together? The plus 3 and the negative 5, yes, 3, take away 5, is minus 2. So that's the answer to that. They're not all as easy to spot as that, but these are. So here we go, brackets, v beginning. I've got a positive 20 here, so it could be 4 and 5, but 4 multiplied by 5 gives 20, but added together they give positive 9, not negative 9. But can you see that if I have negative 4 and negative 5, a negative multiplied by a negative gives a positive, so they do give me the positive 20. And if I add together the negative 4 and the negative 5, I do get minus 9v. So that's the answer. So finally, draw the brackets without even looking at the question almost. I can see we're going to get a w at the beginning. Now I want two numbers that multiply together to give negative 42. The only way we can do that is if one of them is positive and the other one is negative. Now I know from my times tables that 42 is 6 times 7, and we want to get a positive 1w here. So the 6 and the 7, to get a positive 1, I want to have plus 7 and minus 6. That will give me the 1 there. So that's the answer. Have a go. Level 7. Press the check button regularly. And when we get to level 8, this is as hard as it gets. We have a quadratic expression, but the coefficient of x squared in this case is not 1 as it was previously. This is a method that I have used over the years that's always worked for me. And the little trick is I do some writing over on the right hand side of the page. And the fact that I do it on the right hand side of the page helps me remember that this is something different, and the way I solve this is by writing on the right of the page. It just helps me remember the method compared to all the other things you have to remember. So let's see. First of all, I multiply the 3 by the 25, and that gives me 75. 3 25s is 75. And then I write down all the factor pairs of 75. So 1 and 75. But of course it could be minus 1 multiplied by minus 75. But let's not worry ourselves about that just yet. It's not an even number, so I know 2 isn't a factor. But 3 is, because 3 times 25 gives me 75. It's not even, so 4's not a factor. 5 is a factor. How many 5's in 75? 15. So 5 times 15 is 75. So because 3 was a factor and it goes into 75 an odd number of times, I know that if I double that, I would have to halve that, which would give me a fraction. So I know 6 isn't a factor. 7, no. 8, no. 9, no. 10, no. 11, 12, 13, 14 doesn't go into 75, and now I get back to the other side. So those are the three factor pairs of 75. And what I have to do now is find a pair of them that will give me this plus 20 in the middle. So which of these, if I combine them, will give me plus 20? I think it's this pair here, the 5 and the 15. So the next thing I do is I write down this expression again. But instead of writing 20x, I split it up into the 5 and the 15. And then I have my 25 that was there at the end. And then I factorize these in pairs. So the first pair, there's a factor of x. So that will leave me with 3x plus 5. And the second pair, there's a factor of 5. So that will leave me with 3x plus 5. Whoa, look what's happened. The two brackets are exactly the same. So I could bring the brackets as a common factor to the front. 3x plus 5. And to give me this first term, I'll need that x there. And to give me the second term, I'll need that plus 5 there. So the first brackets, I've got 3x plus 5, and the second brackets, x plus 5. I think I've got the answer. And we can always check by multiplying out these brackets to see if we get back to where we started. Second example. We start off by multiplying the 6 by the 20. 6 times 20 is 120. And then write down the factor pairs of 120. I think that'll be quite a lot. So 1 multiplied by 120, 2 multiplied by 60, 3 multiplied by 40, 4 multiplied by 30, 5 multiplied by 24, 6 multiplied by 20, 7 doesn't go, 8 multiplied by 15, 9 doesn't go, 10 multiplied by 12. And I think that's all there are. And I need a pair of these that will add together to give me the 23. So let's see which two will add together to give me 23. It looks like the 8 and the 15. So now I write this down. 6y squared. I split up the 23y into an 8 and a 15. So plus 8y plus 15y plus that 20 at the end. And then I factorize these in pairs. Y, oh, I've got a factor of 2y, lots of 3y plus 4. And then here I've got a common factor of 5. So that will give me 3y plus 4. And if all's gone to plan, the two brackets will be the same. So 3y plus 4 multiplied by the 2y plus 5. And again, you can check by multiplying out these brackets. Now an example involving the letter Z. 9 multiplied by 20 is 180. So let's write down the factor pairs of 180. 1 and 180, 2 and 90, 3 and 60, 4 and 45, 5 and 36, 6 and 30, 7s don't go, 8s don't go, 9 and 20, 10 and 18, 11s don't go. 12s. Yeah, 12s will go 15 times. 13 won't go. 14 won't go, and we're back to the other side then, going back up the other side. So these are the factor pairs of 180, because the number in the first column multiplied by the number in the second column gives us 180. But both of these numbers could be negative, because negative 30 times negative 60, for example, will give me positive 180. So I have to bear that in mind. And because I want to find two of these that will add together to give minus 27, I am going to be thinking that they're both negative. So which of these will add up to give me 27? It looks like the 12 and the 15, if they're both negative, will add up to negative 27. So this is the pair I want. Okay, it's plain sailing from now on. You know the routine. 9z squared, then split up the minus 27 into a minus 12z minus 15z plus 20. Factorize the pairs, so we have 3z lots of 3z minus 4, and then let's take a factor of minus 5 out of here, which will leave me with 3z, and then if I divide the 20 by the negative 5, I'll get negative 4. Both brackets are the same. 3z minus 4, lots of the 3z minus 5. And that's the answer. Okay, our last example. Multiply the 15 by the negative 8, and you'll get negative 120. So let's write down the factor pairs of negative 120, but let's forget the signs just for now, because they could be either way round. One could be positive and the other could be negative, vice versa. So let's just write the numbers down. 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 7s don't go, 8 and 15, 9s don't go, 10 and 12. Now those are the numbers, but we know one of them has to be positive and one of them has to be negative in order to get a product of minus 120. So just bear that in mind to find two that will add together to give the positive 14. Well, I think if we have the 20 multiplied by negative 6, that will give us our required product, but also if you add these two together you get positive 14, which is what we want. So this is the factor pair we're going to use in this question. Right, you know the routine by now. 15w squared minus 6w plus 20w minus 8. These two have got a common factor of 3w, and that will leave me with 5w minus 2. And these have got a common factor of 4. So plus 4 lots of 5w minus 2. The two brackets are the same. Write that down at the beginning. And then we got the 3w plus 4. Okay, now it's your turn to have a go at the online exercise. Don't forget to press the check button regularly as you're working through the questions to see if you're getting them right. And if you make a mistake, have another think and correct your answer and then press that check button again. Don't forget to claim your trophy when you've got to the end. And there are Lots more activities on the Transome website for you to have a go at to improve your mathematics, and you can claim hundreds of trophies. So, what are you waiting for? Get going! Bye!
You can find Transome Mathematics at www.transome.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Transome subscriber.